my name is Julianne Lucero, and for my summer project, I'll be creating a wind turbine to produce clean energy sustainably. The purpose of this project is to use wind power to efficiently generate electricity in a sustainable way, aiming to reduce pollution in power plants. Wind power is the best energy source to create electricity and benefit the world at the same time because wind is free. Once the installations have been paid, the electricity cost will eventually be reduced and could cut your carbon footprint, which is really good. In figure 1, the picture on the right, it shows the graph rates in the world, and as you can see, the data is slightly staying constant and steady based on the average wind installations in the world. And in figure 2, it shows the wind power capacity data in the year 2020. Texas is the top state to have the most installations, and our state, Hawaii, is approximately in the middle with 206,000 megawatts. The wind is very important in the world because it is not contaminated. According to the Molelo, the Hawaiian wind god Kapa'a chants the names of all the winds of Hawaii when he goes canoeing, and was actually credited with inventing the sails to help transport humans quickly by sea. Thinking about the project, the blades are like the sails on the boat, and the wind pushes it to create more power. Each ahupua'a has a wind name, and for this project, I'll be using Haupe'epe'e, the winds of Kalihi, to push the blades of the turbine at the highest point of my house to generate electricity. During the thought process, the vertical axis wind turbine was chosen over the hot design, shown in figure 4, which is right down here. In figure 4, because of its ability to be insensitive to wind direction, and it's known to be cost efficient, and they say it would less likely take up less space. For those who don't know what a VOT is, it stands for vertical axis wind turbine, and it's basically perpendicular to the wind stream, aka vertical. In figure 3 right here is a schematic example of what a VOT appears to look like. I feel like the VOT would be a great design for my project, so then I used a CAD software, Fusion 360, to specifically model the design of how I physically want it to look like. My vision was to make the turbine with materials around my home, very cost efficient and super lightweight compared to the other designs that others have built in the past. Then after designing, I did a mini model. A mini model was built with things I found in my home, things I used in my everyday life. The materials I used were just cans, a couple of chopsticks, and a water bottle. I created this model to ensure that this design would work successfully. Then after I succeeded, the real prototype in figure 6 were to be built, made with materials including wood, nuts, a plate washer, and most importantly, PVC pipes. While the prototype was being built, the Arduino was used, and the main task was to find a code that would get the temperature and humidity sensor to work. In figure 8, there's two pictures are provided with the schematic of the wiring. This turbine will be built 2 feet high and will be stationed on top of my roof to catch better wind while being held down with 2 flat bungee cords to secure the turbine. Then from my results, after many attempts, I got the temperature and humidity sensor to successfully work, but without the LCD screen. The temp and humidity sensor is basically a calibrated digital signal output of the temperature and humidity based on the surrounding air. The purpose of the DH11 is to be a weather station in this project and show that when the temperature changes, so does the speed of wind. And in figure 10, it shows the sensor, how the sensor looks up close. Although I haven't collected any data due to the prototype having struggles when trying to build it, the mini prototype was successfully built, but the light bulb wouldn't be able to light up. I couldn't figure out why, but I just proceeded with building the real model, and for me it was really difficult. The plate washer was the whole problem. I guess it wasn't sturdy enough for it to hold the blades. It just kept falling. So in the future I plan to weld it together. I plan to weld it at my high school. So I'm just waiting for my past teacher to respond back to me. But in conclusion, although I did not finish my project, in the future a MQ135 sensor and a DHT sensor will be used to measure the wind speed, temperature, and humidity. The MQ135 is a wind speed sensor and will be an alternative for the multimeter to measure the voltage. Instead of successfully trying to power just a small light bulb, I will try to power the light bulb in my room. I have learned many things in the process of building this project. I've learned how to work the Arduino and advance in CAD software. There were hardships in this project, which involved finishing in a span of 6 weeks, finding and fixing a code for the sensor, and finding what materials would be best for the turbine. I plan to continue this project this summer. Then here are my references, and I would like to say thank you to Josh, Leanne, Mervin, Jing, Patrick, Alden, and Kiana. And that's all I have for today. Thank you for listening.